propeller is the most significant machinery system of the ship. No matter what type of propeller it is, ship owners never make compromises on such important equipment as it directly affects the efficiency and safety of the vessel. So, why is the propeller renewed? There are various reasons for which a ship's propeller could be renewed. Some of the significant reasons are damage to the propeller, dynamically unbalanced, and renewing the existing propeller with a new propeller that is of better material or larger blade area. In this case, the propeller is cast in one piece and is made of a complex alloy involving 8 different metals. Long before the actual casting process has been started, the propeller had to be designed. Dozens of variables have to be accounted for to design the most efficient propeller possible. A poorly designed propeller can lead to poor fuel efficiency or low top speeds, and even reduce the lifespan of other ship components. Once a design has been selected, the molten metal is poured into the mold and left to cool. The propeller is so massive that the metal takes a full 5 days to cool and harden. Once the metal is cooled, the mold is broken off, and the propeller is sent to the milling machine. The machine is computer controlled and spends the next 15 days polishing the propeller. After almost 3 weeks of production, the propeller is finally ready to be attached onto the ship. All that work for just a single component on a massive tanker. So how does a ship propeller work? For vehicles running on land, the propelling system which drives them is different. In those systems, the engine powers the shaft which is attached to the vehicle tire to move ahead of the body of the vehicle. However, for ships which are displaced in water, there are no such tires or surfaces where they can ride. The ship is displaced in the water, and the propeller is used to drive the ship ahead or backwards, depending upon the direction of rotation or pitch of the propeller. The engine of the ship is connected to the propeller of the vessel via shaft arrangement. As the engine rotates the propeller, the radiating blades which are set at a particular pitch form a helical spiral, similar to a screw. While doing this, it transforms the power of rotation into thrust, which is linear in nature. This linear thrust will act upon water such that as the propeller blades rotate, it creates the pressure between the surface in front and back of it. Hence, a mass of fluid is accelerated in one direction, creating a reactive force that helps the body attached to the propeller moves ahead. For the ship to move in the reverse direction, the engine and hence the propeller is rotated in an anti-clockwise direction. This will reverse the thrust and the ship will move faster. However, the engine of the FP propeller is always designed for clockwise rotation when sailing ahead, hence, prolonged operation in a stern direction is not efficient. Anyway, if you like this video, don't forget to hit the subscribe button for more updates on awesome videos. Thanks for watching, and see you next time.